In today's session, we are going to discuss about manufacture of urea by total recycle process or ammonium carbamate decomposition process. And also, we discuss about the production of ammonium phosphate and ammonium sulfate. Before going to that, we just recap the first session. In the first session, we have discussed about the production of ammonia by synthesis gas route. There, ammonia is produced by reacting hydrogen and nitrogen in 3:1 ratio in presence of iron or iron oxide as catalyst. The gaseous ammonia obtained is actually condensed to liquid ammonia, and it is obtained as liquid ammonia. We also discussed about the production of ammonium nitrate. Ammonium nitrate is produced by reacting ammonia with nitric acid. The ammonia is actually used to neutralize the phosphoric acid, nitric acid, so that the ammonium nitrate is formed. This production of ammonium nitrate is carried out by two methods. One, the reaction is carried out in vapor phase. In the second, the reaction is carried out in liquid phase. In both the cases, the liquid ammonium nitrate is obtained, that is then concentrated and can be converted into prills in the prilling tower or granulated, or it can be made into crystals by crystallization, or it can be made into flakes. We have seen the properties and applications of both ammonia and ammonium nitrate. Ammonia is used as a raw material in the production of urea, ammonium nitrate, ammonium sulfate, ammonium phosphate, and the ammonium nitrate is actually used as the chemical fertilizer ingredient. It can be used as a fire retardant in food, etc. So today's session we are going to discuss about the manufacture of urea by ammonium carbamate decomposition process or by total recycle process. Here the raw materials required for the production of urea are carbon dioxide from the synthesis gas production and liquid ammonia. The reactions involved are carbon dioxide plus ammonia gives ammonium carbamate. This ammonium carbamate decomposes to urea and water. The because of the variation in the process temperature, there is chances of formation of biurate from urea. To avoid this formation of biurate, the concentrated ammonium carbamate solution or urea solution is maintained just above the boiling point of urea. This is the flow sheet for the production of urea. It has got a autoclave where the ammonia and carbon dioxide are made to react and forms ammonium carbamate. It is an exothermic reaction, so the reactor has to be cooled externally to maintain the required temperature of 185 degrees Celsius. The ammonium carbamate, unreacted ammonia, carbon dioxide, and water are actually formed in this reactor, and these are actually taken to the flash vaporization for the separation of high pressure recycled solution that contains ammonium carbamate, unreacted ammonia, carbon dioxide, and water. From there, it is actually sent to a flash drum to separate the low pressure recycled gases, that is ammonia and carbon dioxide are separated there. So the ammonium carbamate actually decomposes and forms urea. The aqueous urea of 80% is obtained here in the flash drum. From the flash drum, it goes to vacuum evaporator where urea solution is actually concentrated there to about 99% concentration. This molten urea is then sprayed in a Prilling tower to produce urea granules, which contains less than 1% biurate. To avoid this formation of biurate, the temperature of molten urea should be maintained just above the boiling point of 132 degrees Celsius. Let us see the process in detail. Ammonia and carbon dioxide are compressed separately and fed to a high pressure autoclave, which must be water cooled due to high exothermic heat of reaction. The mixture of urea, ammonium carbamate, water, and unreacted ammonia and carbon dioxide results in the autoclave. This liquid effluent is let down to 27 atmosphere pressure and fed to a special flash evaporator which contains a gas liquid separator and a condenser to separate the unreacted ammonia and carbon dioxide and also water from the urea. And these solutions are taken out and recycled. An aqueous solution of carbamate urea is passed to flash drum where further decomposition of carbamate takes place. The off gases from this step can either be recycled or sent to ammonia processes for making chemical fertilizer. The 80% aqueous urea can be used as it is, or it can be sent to vacuum evaporator to obtain molten urea containing less than 1% water, that is 99% urea content. The molten mass is then sprayed into Prilling tower, or it can be granulated to convert the liquid ammonia into granules or prills of desired size. To avoid the formation of biurate in percentage more than 1%, the temperature must be kept just above the melting point of urea, that is 132 degrees Celsius. That is the process taking place in the production of urea by total recycle process. Let us see the properties and applications. The molecular weight of urea is 60. The melting point of urea is 132.7 degrees Celsius. Boiling point, it decomposes above melting point. The specific gravity is 1.335 gram per cc. The technical grade urea contains 46% nitrogen. These are the physical properties. Applications: urea is used as a fertilizer in animal food or feed, urea formaldehyde resin in the manufacture of melamine and adhesives. Next, we will discuss about the production of ammonium phosphate and ammonium sulfate. Here, for the production of ammonium phosphate, the raw materials required are liquid ammonia and phosphoric acid. For ammonium sulfate, it requires ammonia and sulfuric acid. Then potassium chloride is added to produce a mixed fertilizer. The reactions involved are in the production of ammonium phosphate. Ammonia plus phosphoric acid gives ammonium biphosphate. This ammonium biphosphate further in presence of ammonia gives ammonium diphosphate. In ammonium sulfate, ammonia is used to neutralize sulfuric acid to get ammonium bisulfate. This ammonium bisulfate in presence of ammonia gives diammonium sulfate. Or it can also be made by treating ammonium carbonate with hydrated calcium sulfate, that is ammonium carbonate NH42 twice CO3 plus hydrated calcium sulfate, that is CaSO4 2H2, which gives calcium carbonate, water, and ammonium sulfate. Next, we see the flow chart. This is the flow sheet wherein there are three reactors or neutralizers are used here to produce the mixed fertilizer. Phosphoric acid, sulfuric acid are actually made to react with ammonia, which gives ammonium and disulfate and ammonium diphosphate. These are actually taken out from the tank, last reaction tank, and mixed with potassium crystals, that is potassium chloride KCl, and fed to a rotary granulator where the ammonium sulfate and ammonium phosphate are, and along with KCl, these are actually granulated. The granules are dried in a rotary dryer and it is actually screened to get the desired size of mixed fertilizer, and the O size is recrushed and the fines are actually fed to the rotary granulator once again. The process in detail, the two steps in the neutralization and granulation. These are the two steps in the production of ammonium sulfate and phosphate. For neutralization, phosphoric acid and sulfuric acid are added to the first of three continuous mixer reactors. The anhydrous liquid ammonia is added beneath the slurry level in the first neutralizer in an amount equivalent to 80% neutralization. Ammonia is added further in the second and third reactors to obtain conversion to diammonium salt. If a higher nitrogen content fertilizer is needed, the reaction is exothermic, which actually heats the slurry to the boiling point, that is around 130 degrees Celsius. The unreacted and excess ammonia vapors is collected from the top of the tank and recharged below the liquid level. Slurry from the third neutralizer is mixed with potassium chloride KCl and absorbed in a bed of dry recycled fertilizer moving through a rotary drum granulator. This provides a tumbling action to coat recycled material with a slurry film. A rotary dryer is used to reduce the moisture content to less than 1% with 10 with 10 minutes contact time with air at 150 degrees Celsius. The dried product is screened and bagged. This is how we can produce the ammonium sulfate, ammonium phosphate, or mixed fertilizer. Right? Next, we'll see the physical properties of monoammonium phosphate and diammonium phosphate. The monoammonium phosphate molecular weight is 115. The melting point, it decomposes above the melting point. Density 1.8 gram per cc. It is completely soluble in water. Diammonium phosphate molecular weight is 132. It also decomposes above melting point. As soon as it melts, it starts decomposing. Density 1.62 gram per cc. It is soluble in water. These are the physical properties. Applications of this. It is mainly used as a chemical fertilizer. The other uses are as a fire retardant, as a nutrient, yeast culture, etc. Thank you.